Okay, so in this situation we have here, we have a man who buys a car in installment basis. This means you'll be paying $10,000 per month for the next 3 years. So I've drawn here a representation of what's occurring. The present time, right now, time zero, no time has passed. In 1 month, he will pay $10,000. In another month, he'll pay another $10,000. This will continue on until his very last payment, which it will be in 3 years. And since it'll be every month, which is 12 times per year, it'll be in 36 months, he'll make his last payment of $10,000. So this will continue. This goes on and on for 36 times. This situation where an amount is given or received, the same amount every single time in the same time interval periodically, is called an annuity. Okay. In an annuity, we need certain bits of information. We need the amount of the monthly payments. In our case, it's $10,000, which we'll call CF. We need the interest rate, which is 15%. We'll call I. We need the compounding periods per year. In our case, it's compounded monthly. And since there are 12 months in a year, it's 12. If it was compounded semi-annually, this number would be 2. And then the number of years, which this occurs for, this is occurring for 3 years. Okay. And now when we're talking about an annuity, what we want to know, we know that these payments are going to occur in the future, right? But we want to know right now, what is the value of these payments? What would someone be willing to take right now that is equivalent to these future payments? That's what we call the present value of an annuity. And that's given us by this formula right here. And as you can see, every variable in this formula we have defined right over here. And in whatever problem you come across in your work, as long as you define the variables here, you will use this formula again. Whenever you have an annuity, just like the situation, which is a periodic payment of the same amount. So we've gone ahead and substituted those values in right here, which has given us a total value of $288,472.67. That is the present value of an annuity. It's also, we would consider the price of this car. This is what is the equivalent, this is what the value is of that car today. We could either give them in cash right now, this amount, or we can agree to this loan situation where we pay $10,000 every month for 36 months. But both of these situations are equivalent. So the value of the car today is this amount. We could pay this in cash right now, and it would be the exact same scenario. Okay? So this is how we calculate the price. Now, we're not going to pay this amount today. We're instead going to be paying $10,000 every month for 36 months. So the total amount that we will end up paying is $10,000 times 36, which gives us $360,000. As we can see, that's more than the actual price of the car today. That's because interest is charged. That's because in order for us to essentially borrow money in order to pay for this car, we're going to be charged interest. And now how much interest is we will have to pay at the end of the day, we can calculate by taking the total interest payment will be the total amount that we pay, $360,000, minus the price that we calculated before, the value today of the car. And then we find a difference of $71,527.33. That means because we took out a loan, instead of paying this amount today, we will pay an extra amount equal to this in interest.